Okay. So for sine, we're going to take our, for tangent, we're going to take our sine, which is negative 4/5, and divide that by cosine, which is 3/5. So we do our keep change flip. So that becomes negative 4/5 times 5/3. And your 5's cancel. So you should get negative 4/3. Trying to fit it over there. Who had negative 4/3? And then our cotangent, you can also do the division again. Cotangent is cosine divided by sine. But we already know our tangent, so we can easily just flip that, and it becomes negative 3/4. So our remaining trig ratios are, we have our cosecant, which is negative 5/4. We have our secant, which is positive 5/3. Our tangent is negative 4/3. And our cotangent is negative 3/4. All right, any questions about how we found those remaining ratios? Okay, we got a couple more and then we'll be done. So let's talk about periodic properties. So this is when it is greater than 360. So take a minute and copy these down. And again, we're going to look at our unit circle and find our answers. So 450 is greater than 360. So that means that we're going around the unit circle past one full revolution. So 450, this is a coterm, because we talked about coterminal angles last week. And we said coterminal angles, we can add or subtract 360. And coterminal simply means that it has the same terminal side. So what angle on the unit circle do you think is coterminal with 450 degrees? Not four. Wait, not what quadrant. No, it's what angle. There's an angle on the unit circle that is coterminal with 450. So if you take 450 and subtract from that 360, what do you get? $90. You get 90 degrees. So the sine of 450 is the same as asking what is the sine of 90 degrees. A 450 degree angle is at the same place. So if you rotate around the unit circle 360 degrees, and then you go an additional quarter turn, this angle here is also 450. this is where it would be. Except for that angle, you would have your initial side here, and you would rotate around more than once, which is why it's more than one revolution. All right, so go ahead, look at the unit circle, see the sine of 90. Sine is your y value, so you should have 1. So the sine of 450 degrees is 1. Okay, in radians, 5 pi, remember that 360 is equivalent to 2 pi. So what this means is I'm actually going around the circle 2.5 times. So if you take 5 pi and you subtract 2 pi from it twice, you get pi. So the cosine of 5 pi is the same as the cosine of pi. So this is my initial side, and I'm going around 1, 2.5. And that's why it's 5 pi. But 5 pi is the same as, is at the same place as pi. So go ahead and look at your unit circle and find the cosine of pi, and you should get -1. So the main thing is determining where on the unit circle you can find these angles. All of the angles will be on the unit circle, but what you'll need to do, so go ahead, if you don't have a degree between 0 and 360, or in radians between 0 and 2 pi, you will need to add or subtract 360 degrees until you get within that unit circle. Or for this one, if you know that it's -135, you could just realize, okay, well now I'm going clockwise. So for -135, this is my initial side. I'm going to rotate 90 and then an extra 45, and this is going to be my -135. -135 would be right here. So -135 is the same as the tangent of 225. And because that's one of our angles where sine and cosine are the same. Oh, I didn't write the answer for the last one. Hold on one second. So we had -1 for question B. And for question C, I'm dividing sine and cosine. They're both negative. And in quadrant 3, we know that tangent and cotangent are positive. So that would be a +1. All right, 17 pi over 4. So I need to subtract from that 2 pi. Now, in order to subtract a fraction, when you have a fraction, what do you need to have? A common what? A common denominator. So I'm going to multiply this one by 4. So that's 17 pi over 4 minus 8 pi over 4, which is 9 pi over 4. Now 9 pi over 4 is still greater than 2 pi, so let's subtract it again. Let's take that 9 pi over 4 and subtract 8 pi over 4 again, and this time you get pi over 4. So we're looking for the sine of pi over 4. Go ahead and go to your unit circle. And when you're looking for the sign of pi over 4, the sign of pi over 4 is right here. So the sign of pi over 4, I'm going to go ahead and erase. Is positive root 2 over 2. And that would be your 4 answers. So if it's not within the unit circle, we will need to add or subtract 360 or 2 pi. All right, let's go back to finding our remaining trig ratio. So go ahead and copy this down. So this time they told us tangent and they gave us another clue. They only gave us 1 this time. So we have to find 5. So the first thing we need to do is figure out what quadrant we're in. And we can see here that tangent is positive. So tangent is positive. So because tangent is positive, we know that it's either going to be 1 or 3. So we can automatically rule out these 2 quadrants. But then it says that sine is less than 0. So if it's less than 0, does that mean it's positive or negative? Negative. Any number less than 0 is negative. So sine is negative. So what quadrant am I in? Am I in 1 or 3? Show me with your fingers. Yep, we're in 3. So we know we're in quadrant 3. So let's go ahead. Now, we got to go back to some geometry, because do you remember what 2 sides of the right triangle tangent uses? Remember how it's opposite, adjacent, and hypotenuse. Does anybody remember what 2 sides we use for tangent? Opposite and adjacent. Good. So go ahead and draw your right triangle, because we need to do a little bit of Pythagorean theorem. And I'm putting theta. Well, I guess I should draw it. Well, we'll leave it. Okay. All right, so we know that opposite, because tangent is equal to opposite over adjacent. So the only side we don't know on this right triangle is what? What's the third side? It's opposite, adjacent, and what's the third one? Hypotenuse. We need to find the hypotenuse. So opposite is a 1, adjacent is 2, and we need to find the hypotenuse. So we're going to use the Pythagorean theorem. So that would be h squared equals 1 squared plus 2 squared. So h squared equals 1 plus 4. H squared equals 5. And the hypotenuse is the square root of 5. So now that we have all 3 sides, we can find all 5 ratios. So I'll give you a minute to copy that down, how we found that. So I'm going to go back to my unit circle. Not to my unit circle, sorry. back to my triangle. And I'm adding that measurement to my triangle. So I have all three sides of my triangle. So we can easily find the missing 5 ratios. So it's easier when they give us two different ones, because we don't have to do the Pythagorean theorem, but they only gave us one. So we need to find the third side. So let's go ahead and write our 5 missing ratios. So we'll start off with cotangent of theta. That's the easiest to do. So we're going to flip the 1/2 and just get a 2. And then sine is equal to opposite over hypotenuse. Let me label these 3 sides of our triangle. This is hypotenuse, this is opposite, and this is adjacent. I'll go ahead and add that too. So sine equals opposite over hypotenuse, which would be a 1 over the square root of 5. We can't leave it that way, so let's rationalize it. So that would be my final answer. Now we know we're in quadrant 3 and everything is negative except for tangent and cotangent. So don't forget to add a negative in front of our sine. So sine is negative. So that would be my sine. That's my cotangent. Okay, let's do the sister. The sister to sine is cosecant. So I'm going to take this fraction here, this 1 over root 5, and flip it. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So hypotenuse is root 5, opposite is 1. So we just have a root 5. And don't forget to make it negative because we're in quadrant 3. Okay, and then we have the cosine. Cosine is adjacent over hypotenuse. So that would be a 2 over root 5. So let's go ahead and rationalize that. And you get 2 root 5 over 5. And again, because we're in quadrant 3, we have to make that negative. And then our last one is the secant. Secant of theta. Secant of theta is hypotenuse over adjacent. So that would be root 5 over 2. And again, we have to make that negative because we're in quadrant 3. Any questions about how we work through example 2? It's getting a little trickier. Okay. All right, last one. Let's go ahead and at least get it started, and we'll probably finish it Tuesday. But copy it down. we might actually finish it today. This one won't take long. So sine is equal to opposite over hypotenuse. Val, can you sit up for me, please? Thank you so much. So sine is equal to opposite over hypotenuse. So we're going to make our right triangle. We know we're in quadrant 3. So this is where we're at. And we need to find the adjacent side. So let's make our right triangle. Do you remember your Pythagorean triples from geometry? There is a couple of them. Okay, so we're going to put 13 here and 5 here, and we're trying to find the adjacent. So this is, again, without a calculator. We need to find the third side. Yes. So when we're talking about the distance, we're actually not going to include the negative. That negative just helps us figure out what it told us the quadrant, but when we're trying to find a measurement, it cannot be negative. So the length of my hypotenuse has to be positive. The length of the opposite, we're gonna look at the absolute value. Okay, so this might be a little tricky because you don't get a calculator, but 13 squared is 169. Do you know your perfect squares? Okay, what's 5 squared? 25. Now go ahead and subtract 25. And you get 144. So that is a perfect square. Does anybody know the square root of 144 though? 12, good. So we can add that to our triangle now. Now we have all 3 sides. And we can easily list the remaining 5 ratios. So I know this is my hypotenuse. I know this is opposite. And I know this is adjacent. So this one we don't have any radicals to deal with, so we don't have to rationalize. So it'll go super fast. So we know that the sister to sine is cosecant. So that's going to be a negative 13 over 5. As long as the fraction is negative, it doesn't matter where you put that negative. You could put the negative in the front. You could put the negative in the numerator. You could put the negative in the denominator. It just needs to be negative. So we got sine and cosecant. Let's go ahead and do cosine and secant. Cosine of theta is adjacent over hypotenuse. And adjacent would be what? 12 over hypotenuse, which is 13. Now in quadrant 3, is cosine positive or negative in quadrant 3? And that's why I put this up here. Cosine is negative, so we got to put a negative in front. And then we have the secant, which is going to be negative 13 over 12. Exactly, they're reciprocals. Okay, tangent and cotangent are the only 2 that are positive. So the tangent of theta is opposite over adjacent. So that would be 5 over 12. And the cotangent of theta is adjacent over opposite, which is 12 over 5. And that is it. Okay.